A very good day to Dr. Karia. I'm Shalini and my teammates Tanuja and Faiza will be presenting our instrumentation project. As the first part, I would like to present our regarding the PNID. We identified there are 6 control loops, and the first control loop it has 2 controllers, so this is known as a cascade control configuration. It has 2 controllers, LIC and FIC. As a primary measured and control variable, which is to control the level inside the deodorizer unit. And FIC, second measured and control variable, will be controlling the flow rate of effluent stream of this heat exchanger. Manipulating the flow rate of bleached oil from this measuring tank entering into the deodorizer unit, and the disturbance will be the feed entering into the deodorizer unit. Second control, which has a feedback control configuration, where it is controlling the temperature of effluent stream of this heat exchanger, manipulating the flow rate of steam, and the disturbance will be the temperature of steam. Third loop also has as a feedback control configuration, where it is controlling the level at the bottom of deodorizer unit, manipulating the flow rate of deodorized oil entering into this heat exchanger, and disturbance will be the feed entering into this deodorizer unit. Fourth control also has the feedback control configuration, where it is controlling the temperature of effluent stream of this heat exchanger, where manipulating the flow rate of cooling water, and the disturbance will be the temperature of FA distillate that's coming out from the scrubber entering into the heat exchanger. And fifth control loop also has a feedback control configuration, where it is controlling the temperature of RBD oil at the effluents of this heat exchanger, manipulating the cooling water, and the disturbance will be the temperature of cooling water. Sixth control configuration, which is feedback also, where the flow rate of where we're controlling the flow rate of steam inlet into the spudging coil of the deodorizer unit. And the manipulated variable also will be the same, where it is manipulating the flow rate of steam entering inlet to the spudging coil. And the disturbance will be the feed into the deodorizer unit, as well as the level of oil at each tray.
There are a few possible types of instruments and valves. So move on to thermal sensor. The first one is RTD, which is resistant temperature detector, where the temperature information is provided in the form of change in resistance of a metal wire element as a function of temperature. So there are two, which is nickel and platinum. So the obvious difference will be in the temperature range. The next one is thermistor, where the nominal resistance of at some temperature may change by 1 kilo ohm for a 1 degree Celsius change in temperature. They have two range limit, which is upper limit and lower limit. So the last one is thermocouple, where we have type S and J. So the difference will be in the sensitivity and also the range. The next one, move on to level sensor. The first one is capacitance level sensor, where it will monitor the tank level in chemical, food, water treatment, power and brewery industries. The next one is float switch level sensor, which is when a product is added or removed, a float is raised or lowered, which opens or closes a circuit as the level rises or falls. So these will make the float to move. The next one is optical level sensor, where it measures the tank level or leak detection. Okay, move on to flow sensor. The first one is pitot tube flow meter, where it measures airflow, and it's suited for a variety of environmental extremely high temperature and a wide range of pressures. The next one is turbine flow meter, where it measures the volumetric total flow or the flow rate, and it maintains high flow rate over an extended flow range. And the last one is orifice flow meter, where orifice flow meter has a careful calculated hole in the center and is placed into the pipeline to lower pipe diameter and hence provide obstruction. And It is not suitable for the slurries because it has clogging problem and have changing characteristic due to erosion, corrosion, and scaling. So this will reduce the accuracy. And the last one is control valve. We have three, which is gate valve, drain valve, and piston valve. So gate valve is not suitable for regulation or throttling of flow. Drain valve allows most of the dirt or sand that built up in the bottom tank to drain from the hot water heater. And the last one, piston valve, is used as well with heat transfer oil and various chemical, and also is capable of draining tanks that contain slurries or even powders.
Finally is our choices and its justification. For control loop 1, we have choose capacitive as our level sensor, and control loop 1 involves in point level measurement and not continuous. Switches are simple to calibrate and can be installed both horizontally and vertically, and no moving parts to wear out, as it has advantages of active build-up compensation. For the flow, we have choose turbine, and it is versatile, easy to maintain, very durable, and wide range of uses. And we choose gate valve for the control valve, as it is fully open and closed for regulation on oil. For the control loop 2, we have choose thermocouple type J as our thermosensors, and it is applicable for a wide range of temperature and other advantages such as high sensitivity, inexpensive, good repeatability, low pressure loss, and good vibration resistant. And we choose the same as control loop 1 for control valve, which is gate valve, and it is fully open and closed for regulation on oil. For control loop 3, we same as control loop 1, we have choose capacitive for level sensors, and the measurement occurs on point level and not continuous. For the control valve, we have two control valve, which is drain valve and gate valve. For drain valve, it can release and excess oil from the bottom of the deodorizer unit, and for gate valve, it is fully open or closed for regulation on oil into heat exchanger. For control loop 4, we have choose thermocouple type J. Also, it has the broadest temperature range with high sensitivity, and gate valve, and it can be fully open or fully closed for regulation on oil into heat exchanger. For control loop 5, we have choose resistive temperature defector or RTD platinum for our thermosensors, which has good thermal contact in liquid bath and sensitive and provide excellent long-term stability. And we have choose gate valve, and it can be fully open or closed for regulation on oil or control loop. For control loop 6, we have choose turbine, and it has high accuracy, good repeatability, low pressure loss, good vibration resistant. And piston valve for our control valve, and it can control the motion of fluid along tube or pipe by means of linear motion by piston within a chamber or cylinder. That's all from our group on the project instrumentation. Thank you.